Good morning everyone. I am Tanushri Dalai from Civil Engineering branch. In the last class, we discussed about the numerical based on method of joint, and here we solved the force along the BC by summation of Fx equal to 0. So we got the force along BC, that is equal to 707.1 Newton, which is compression in nature. And now we will solve the force along BA. So for that we have to take the equation of equilibrium, that is summation of Fy is equal to 0. That means the summation of all the vertical forces are equal to 0. So here you can see, as per the joint B, one vertical force along the member BC, this member BA is present, so that we will take the force along BA as FBA, which is tension in nature, and the direction of this member force is downward in direction. So that's why we can take this force as negative. So here FBA is negative, and then one inclined member is there, which is BC member, and the force along the BC is FBC. So by resolving this inclined member force along the vertical direction, we can find out another vertical force. So by resolving this inclined member force along the vertical direction, the value of the force will be modified as FBC cos 45. And the direction of the member force is upward in direction, so that's why we will take the sign of this member force is positive. Hence, the net summation of vertical forces are in this way, like FBC cos 45 minus FBA is equal to 0. And we know about the member force of BC, which is 707.1 Newton. So put the value here. Hence, we will get the value of FBA as 500 Newton, which is tension in nature. So in this way, we found out the value of force along BC, which is 707.1 Newton, and the member force of BA, which is 500 Newton, which is tension in nature. Hence, according to the question, we have to find out BA and BC member force, which is already completed. So this problem is solved now. Now, we will solve another problem based on method of joint. So here is your question. Analyze the truss as shown in figure. Bit I, determine the external reaction, whether it is tension or compression, and bit 2, determine the internal forces in each of the member. So here is your structure of truss. So you can see it is a combination of two triangular portion, and this truss consists of 1, 2, 3, 4 and 5 numbers of member. And here at joint A, hinge support is provided, and at joint D, roller support is provided. And at joint B, one vertical force of 10 Newton is provided, and at joint C, two numbers of forces are there. One is 10 Newton, which is vertically downward, and another is 10 Newton, which is horizontally right side. And the size or the dimension of this member is 5 meter along all the sides. So basically it is a square kind of truss. Now we have to draw the free body diagram of this structure. So you can see, because the joint A provided by hinge support, so that's why here two numbers of reactions there. One is vertically and another is horizontally. And at joint D, one vertical reaction is there due to roller support. So first of all, we need to calculate the external analysis, that is the reactions value we need to find out. For that, we will take the help of equation of equilibrium, that is summation of Fx equal to 0, summation of Fy equal to 0, and summation of moment about A is equal to 0. So first of all, summation of Fx equal to 0. So Fx means the numbers of horizontal forces. So we can see in this figure the horizontal forces and reactions. So here Ax is one horizontal reaction, and here 10 Newton is. So here Ay is one vertical, 10 Newton is another vertical, here 10 Newton is another vertical, and dy is vertical. So to calculate the reactions value, first of all we need to put the horizontal forces. So Fx is equal to 0. So here Ay and 10 Newton, these two are horizontal forces and reactions, and both are in right side direction. So that's why both are positive. So Ax plus 10 is equal to 0. Hence, Ax is equal to minus 10 Newton. So from horizontal equation, we can find out the value of Ax is equal to minus 10 Newton. Now comes to summation of Fy is equal to 0. So for Fy, we need to put the vertical reaction along with the vertical forces. So the vertical reactions are Ay and dy, and the vertical forces are 10 Newton and 10 Newton. So Ay and dy directed to upward, and 10 Newton and this 10 Newton directed to downward. So that's why Ay and dy are positive, and this 10 Newton and 10 Newton are in negative. So that's why the equation should be Ay plus dy minus 10 Newton is equal to 0. Hence, Ay plus dy is equal to 20 Newton. Now comes to moment calculation. So summation of MA, that is moment about A, is equal to 0. So to calculate the moment, we have to see what are the forces and reaction we need to calculate for the moment about A. So this 10 Newton and this 10 Newton and the reaction dy we need to calculate for the moment about this point. And this Newton 10 kilonewton and this Ay and Ax should not be considered for the moment about this point because it is connected to this member and this support. So that's why we have to neglect all these things. So first of all, for this reaction, what is the moment about A? So dy into the distance it will cover, that is 5 meter. So dy into 5 and the sign of this should be positive due to sagging moment. Then for this horizontal force, the moment about A should be 10 into 5 and it will give hugging moment towards the point A. So that's why 10 into 5 should be the moment for this horizontal force. Similarly, for this force, it will downward in direction. So that's why it will give again sagging moment towards the point A and it will cover this much distance, that is 5 meter towards the A point. Hence, the equation should be minus 10 into 5 minus 10 into 5 plus dy into 5. Hence, from this equation, we can find out the value of dy, which is equal to 20 Newton. Now, we can put this dy value in equation of vertical force is equal to 0, by which we can get the value of Ay, that is equal to 0, because Ay plus dy is equal to 20 and dy is 20. So that's why Ay is equal to 20 minus 20, that means 0. So today this much. We will discuss the internal analysis in the next class. Thank you.